So hello, everybody. My name's Ray Fix. I recently actually joined the board of the iTecSD group. I'm happy to have joined. So a little bit about myself. I'm a Macintosh. I was a late adopter. My first Macintosh I got in 1985. Which was a year after. And actually, my dad bought it for, he was a high school English teacher and got one of the Macs into our house, and I played with that and the Amiga. I'm not sure which one I liked better, but at the time, the Mac was certainly nice for doing a lot of things, especially desktop publishing. So today, so in terms of Swift, Swift is a new language from Apple, and I'm going to be talking about why they're putting so much emphasis and spending so much on Swift, and why it matters and why we should care about this new programming language, what it's going to mean for us. Okay, so the year is 2005, and the longtime Apple enthusiast and observer, critic, John Siracusa. Who knows John Siracusa? Yeah. John Siracusa is, writes an article in Ars Technica called Copland 2010. So what Copland refers to as an operating system that Apple was trying to make to replace, at the time, OS 9. And OS 9 lacked a bunch of features, namely preemptive multitasking and memory protection. So it didn't have these two things, which meant any app could write to a bad place in memory and everything would crash. The whole operating system would crash. And it was getting woefully behind. This was about 1994 that this was happening. And they were trying to they were in the process of going from the 68K to the PowerPC architecture. Many things were happening, and it was difficult to make that change, and they ended up never making that change. It almost killed Apple. Apple, as maybe some of you experienced, were there for. Apple almost went under, but of course we know that Apple acquired Next, and the Unix operating system, or actually Mach kernel, which later became a Unix operating system, now known as OS X, came, and that really changed things around. But what John Siracusa saw was the fact that the APIs, and by API what I mean is application programming interface. When you go to write a computer program, you need to write against these interfaces that the system provides. And he saw this API as being too low level of an abstraction. That means you had to worry about too many details in order to program your computer, and it meant a lot of bugs and crashes. And even though it wasn't the operating system that was taking you down, this low-level abstraction, Cocoa, he felt was another crisis in the making. And so he's writing this in 2005. He calls it 2010 because he felt maybe it's going to be about 2010 where this crisis comes to a head, and it's going to lose out against Microsoft C#, for example, or the other scripting languages. And he even hedged in that article and said, well, maybe 2010, maybe 2015, somewhere in there. But he didn't want to put it too far out in the future because then people don't think about it as being like a real problem. So along comes 2010, and Apple is doing great, actually. And that's why it's so hard to predict technology. Since then, some things happened to Apple. They came out with the iPhone, and people seem to like that. What it meant was, now that we're down to this basic small device, it's okay to have a language that has a very low-level abstraction because you want to use the resources on that machine as efficiently as possible. And that's what ObjectiveC and Cocoa was allowing programmers to do. So it sort of pushed off that problem. But he said, you know, this is still a problem, guys. And he actually wrote another article in 2010 stating that he thought that it's still something that Apple needs to address. Well, that same year, Chris Latner, an Apple engineer on the development team, started a language that would later be called Swift. And in fact, a couple of my acquaintances joined Apple in 2012. And when I asked one of them, so what are you working on at Apple? They said, well, there's a lot of C++ at Apple. That's all they would tell me, actually. And so here's an example of Objective-C. So I don't expect you to follow this, but this is sort of 2010 Objective-C. It got a little better since then, but you can see there's a lot of like syntactic noise is what I would call it in this, where I just want to order a pizza. I'm making an order. Ray is the order, and I'm making a cheese pizza. So who in here has done any Objective-C? Okay, good number of hands. And so, this is doable, but again, a lot of syntactic noise going on here. And so then there was WWDC 2014. I was fortunate enough to be able to attend, and I was in the audience listening to all the announcements, and there was a definite enthusiasm in the air, and this was the theme. It was Write the Code, Change the World. So there was definitely a theme about, as there always is at WWDC, about programming and APIs. And this year was no exception. The reveal was, hey, we've been working on this language for the last 4 years, and they described it as Objective-C without the C. Now, C goes way back, I think, 40 plus years, maybe even longer. And Objective-C also goes back quite far, at least 20 years, I would guess. And they said, hey, we've made this new language, and it contains all of these great features, and they listed closures and namespace and generics and type inference, multiple return types, and some of these other things that are really awesome that aren't in bold, but functional patterns and operator overloading and clear mutability syntax, super important. Compiled to native code, optional types, lots of features. And to demonstrate this, they opened what's called a playground. And a playground makes this new language very accessible to even the beginner. In fact, this is a playground that you can get from Apple. So I happen to have that playground here, and I'm not going to use the beta. Just going to open this playground. Now my screen is like at a crazy resolution here, so I made the text real big, but you can see. So the code is right in here, and maybe you can see some of this code. But there's explanation of the code mixed in right in with the code itself. And I can click, oops, I didn't mean to do that. You can do an Option Command Enter for those of you that like command shortcuts and get the accessory view. And here I can see that code in action running. It's pretty cool, right? And I can make changes to the code, and you look and you can see it's executing this line of code. And for example, the impulse magnitude, here I can bump up the impulse magnitude, and now you can see the balloons are flying quite a bit faster than they were just a moment ago. So you can interact with it using these new things called playgrounds. Pretty cool. So why is language choice important? This was a graph that they presented at the State of the Union, the platform State of the Union, where they graded different languages. And these are Apple's grades, not mine. So on the y-axis, we have the app performance. How quick, how fast, how performant is the language. So up here, a very performant language is C. And on the x-axis, we have developer productivity. That means how many lines of code do I have to write in order to get some piece of functionality? And you can see that C, they graded, these are their grades, not mine. They graded C as being very non-productive. You have to write a lot of code in order to get something, but it's going to be super fast, so that's good. And then we can see, you know, Java is doing a little bit better here. Actually, Java is doing better than Objective-C in terms of productivity, and that's Apple saying that. Thought that was kind of amusing. We had, over here, we have the scripting languages. So JavaScript, Python, Ruby, Perl. These are well-known. Lua is one that's put embedded inside of games quite a bit. And these are incredibly productive, but they lack the performance that a compiled language or a just-in-time compiled language gives you. So obviously they were introducing Swift, and they put Swift into this quadrant where there's lots of app performance and really great developer productivity. And I felt bad for this quadrant, so I added one here. I put AppleScript there. Who's used AppleScript? Yes. So maybe there's some AppleScript lovers. It's one of those opinionated languages, I guess. So what does it feel like for a developer that's, say, using Perl and moves over here to Python? So their developer productivity increases. They go in this direction. It should be a good thing, right? So maybe you know this person. He's the XKCD cartoonist, and he's also a Perl programmer, or was a Perl programmer apparently, and he wrote this cartoon. And his friend says, "You're flying, how?" And he calls back, "Python. I learned it last night. Everything is so simple. HelloWorld is just print hello world." And the friend says, "I don't know, dynamic typing, white space." These are the opinionated parts of Python. And he says, "Come join us, programming is fun again. It's a whole new world up here. But how are you flying?" "I just typed import anti-gravity." "That's it?" "I also sampled everything in the medicine cabinet for comparison, but I think it's the Python." Anyway. So I thought that was amusing. But let's go back to the Java Hello World. So imagine you're just learning to program, or maybe you want you're teaching someone to learn programming for the first time, and you want them to write Hello World. And Hello World is the program that you first write when you're writing something new in a programming language. And so this is what the Java Hello World looks like. There's a lot of stuff in there. Classes and static members and access control. It's all mixed in. Now, by comparison, this is what the Swift Hello World now looks like. And in fact, some of you are noticing that semicolon there, and that semicolon can also go. Those of you used to programming in C might miss the semicolon, but really, this is actually symbolic of what Swift is trying to do. It tries to get rid of the syntactic noise in your program. That semicolon is not adding any new meaning or enabling you to understand anything new about the program, so why have it there? And so Swift gets rid of it. And going back to John Siracusa, incidentally, he writes a Mac OS X review, and he's done this for every single version of Mac OS X, and they're really in-depth, great reviews if you're into that kind of thing. And maybe this one is his last one, he warns, but he has a section in there on Swift and what Swift's goals are. What matters about Swift is spelled out in the first chapter of the Swift programming language. Swift is intended to be the first industrial quality systems programming language that is as expressive and enjoyable as a scripting language. It's designed to scale from HelloWorld, which we just saw, to an entire operating system. So it covers this incredible range of usages. And here's what Brent Simmons, anybody know who Brent Simmons is? Yeah, he's a indie developer. He wrote Mars Edit, and that later became part of Red Sweater. And he did NetNewsWire, I guess, and that's now Black Pixel owns that. And I believe now he's working at the Omni Group. So Brent Simmons, who's loves Objective-C, says Objective-C looks hard because of the open bracket and close bracket syntax, all those words. It looks kind of mean, actually, like an angry grandpa with a bushy eyebrows who makes you spell out "I am laughing out loud" instead of writing LOL. So he's very much still likes Objective-C quite a bit, but he admits in the same blog post that Swift is a thing and that Swift is happening, I believe is what he said. So if we go back to our pizza example, this is sort of the same code in Swift. And if you're not a programmer, I guess I don't expect you to understand this, but I'm guessing this program looks, even to someone who's never programmed before, a little bit more understandable than what we saw before. So that you can see the abstraction layer is rising. So features of Swift, it's modern and expressive. It lets you express what you want to the computer in very little code. It's designed for safety, meaning the compiler does a lot of checking for you so that your programs don't crash when they're running, but they don't compile. So you get errors before it gets shipped to your user. And to some extent, Objective-C has this, and Swift expands on the ideas in Objective-C and C and C++ to make this type checking things a lot more safe. It's fast and powerful. It's built on LLVM, which is sort of the low-lying technology that enables a lot of these speed ups. It's interactive. You saw the playground example. And also, it's pragmatic. It's not super dogmatic in the sense, it doesn't say you only have to use Swift, but it interoperates with Objective-C as it is today. You can call pretty much any Cocoa Touch or Cocoa interface, and things work great. So how does it make it simple? Here's an example where it's making it simple. Here I have a dictionary, and you can see this dictionary looks things up. It looks up for a given mountain, what's its elevation. And here I'm mapping strings to the elevation in feet. And this is valid Swift. If I type this in, this would compile. But why do I need to type in this definition? The computer, the compiler itself, can look at these lines of code and figure out, hey, I don't need that. I can just have the user write this, and I can deduce from this line of code what that type is, and still do type checking. So it still has the speed. Okay, now Tim Cook, this is the annual meeting. He was talking about the adoption. So one of the purposes of Swift is so that it gets used new people coming to the Apple platform want to adopt this new technology. They want to learn Swift. And when it came out officially in September, there were 11 million downloads of Xcode. People tried it out, and RedMonk had some metrics that showed that Swift was really picking up steam. And developers not only are choosing it, but it's being used in education. He pointed out there's a Stanford University course. It's a little bit more for more advanced, someone that knows programming already, but it's an excellent resource for learning about Swift. And incidentally, I don't know if you probably can't see any of these programming languages on the screen here, but up in the red box here, we see Swift. So on the x-axis, we have like the number of projects, open source projects on a famous site called GitHub. And on the y-axis, we see the rank or Stack Overflow, which is a Q&A site for, oh, that's a good Q, Q&A site for programming. Low battery. So I'm guessing there's some smartphone users out there. How many of you have made a phone call or looked something up important on your smartphone when you've had 5% or less battery remaining?
That was perfect time.
Anyone out there? How about 10%? So how many of you have been thwarted by a dead phone and not been able to make a phone call or look something up on the internet? Yeah. So battery is important, and that's why performance matters. And a lot of the decisions that they made with Swift were thinking about battery performance and how to improve performance. And so how does performance do? This is an interesting blog post. Someone did a measurement of performance, and the numbers might be hard to see here. These slides will be made available later if you'd like to look, or just go to this website. He benchmarked Swift 1.1 and the newer beta that just came out last week, 1.2, and was comparing those with ObjectiveC. And ObjectiveC won in some cases, and Swift did better, slightly better in some other cases. But what was crazy was this bonus round that he did, where he adopted specifically Swift idioms, things that are specific to Swift, which I'm going to talk about a little bit. And he got these crazy improvements in performance here, like 36 times. And remember, performance, so what if it's a few milliseconds faster? Well, that means more battery life in the end. The second reason, or design of Swift, is to get rid of bugs. So this is the sad Mac screen, which could be for hardware reasons, but it can also be for software reasons. And we want to reduce the number of software errors. And Swift uses type checking and a bunch of things in order to, adopts a bunch of idioms to make errors fewer. So this is Dijkstra. How many people have heard of this guy? All right, so there's some. So Dijkstra has a famous paper on goto. Like, you don't want to be using goto. And incidentally, Swift doesn't have a goto statement, and there's no long jump. But the other thing that he says is that our intellectual, so my second remark is that your intellectual powers are rather geared to master static relations, and our powers to visualize processes evolving in time are relatively poorly developed. So there's this whole movement of value-based programming. This is sort of a new thing. Well, it's been around for a long time, but in terms of being adopted by mainstream programmers, it's sort of a new thing. And there's this excellent talk by Andy Matuszek, I think I'm pronouncing that correct. He's a former UIKit engineer. I think he did iOS 4 UIKit, worked on with that team. And he has this talk about value types. And values are great because they have the 3 I's. They're inert. Values don't have behavior. They're isolated, meaning I can have separate threads of execution, and those are safe. We're seeing multiple cores now to speed things up, but multiple cores mean hard work for programmers. And if you use values, it simplifies how you can reason about your programs and reduce bugs. And finally, they're interchangeable. I can take an object. If I take and the example he gives is UI touch. UI touch is an object that gets generated when you touch something on your iPad or iPhone. And that UI touch object has tendrils into the system. And so it's very difficult to mock something up to test it. But if you use value types, then it becomes easy because it's an interchangeable type. I can take that type now and I can create one for a test, or I can send it over the network, or any number of things. And using these values, we can write pure functions, like mathematical functions. So who knows what a function is? Okay, most people know what a function is. So a function takes something in, does something with it, and puts it out. And there's this great talk. He's actually an F# programmer. That's the functional programming language for the CLR for .NET. And he has this talk about railway-oriented programming, where he talks a lot about this stuff. So this is sort of, again, everything old is new again, and people are learning this stuff from functional languages such as Haskell. And so we could think of a function as a tunnel of transformation. So on one end of the tunnel, we have an orange, and out comes an apple. And the cool thing about functions is that they're composable. So I can take in oranges and they spit out apples, and I can have another function that takes apples and spits out pears. And I can compose these two things into one new big function. I don't have to worry about the internal details of that function. Incidentally, you can think of functions also as a stack of things. And maybe a good analogy to use here is sort of like an army paradigm where the lieutenant, or the captain tells the private to do something, and the private first class tells another private to do something, and then that private goes and does that thing, and then reports back up the chain of responsibility. Now, when people do jobs and look at programs, they like to do what's called the happy path programming. So imagine that I'm writing a program that logs you in to a system and updates your user account. So the first step might be to get the email address and password. And the second step might be to verify, is the email blank? Is the password blank? Does the email have an @ sign? Is it well formed? The third step might be, send that information to the server. And then another step is to get the information back from the server and populate my local database. So there's these set of steps that happen when you do some job. And it's nice to think of the happy path. But the real world is a little bit more tricky than that. And if we were to model that with our sort of pipe analogy or train analogy, if you want to think of it as a train, you have an input and an output, but you can always go over to this error path. So how do we handle all of these errors? So there's actually a couple of ways. We can ignore errors altogether. And if you're new to programming, that's a way to do it. But please don't write the software for when I use a CT scanner, for example. So it's not acceptable for something that's mission critical, for example. But it's good for learning. The second way, it's a very popular way and very effective way, is having error codes. And this is actually what Cocoa uses. The problem with error codes is that they mess up your happy path. I had this program that was very simple to describe as these set of steps. But now I have all of these conditions that I need to check. I need to branch here and there and do different things depending on what happens in the program. And it can get pretty complex, and you can lose what the overall meaning of what you're trying to do is. You can get lost in there. It's easy to do that. So your code gets messy. That's the problem with return codes. On the other hand, they're quite effective. So another aspect, or another way to handle errors, is by using exceptions. And exceptions are a way to throw errors. So when the private goes, and so say the private was making dinner for the rest of the people in the barracks, and he goes to the supplies and he says, "Oh, we don't have supplies here. We don't have a certain ingredient that we need to use in the meal." And so he throws an exception, and that populates back. So it unwraps the sort of chain of who ordered that thing, and maybe that populates up to the sergeant, and the sergeant says, "Okay, I'm going to order some more supplies to be brought in." So he handles the error. So this works, but it's not perfect either. So a famous example was I believe it was the Ariane 5 rocket that had some sort of malfunction when it was way in the upper atmosphere. And it was like sort of a secondary system that failed and threw an exception. And no one knew how to deal with that exception because it was sort of this secondary thing that they hadn't really tested and thought about that much. And that exception ended up unwinding the entire stack, blowing through the stack, and causing the main process to exit. So all of a sudden they'd lost all control over the rocket. Fortunately, they could self-destruct it. Another problem with exceptions, and by the way, I'm a big fan of exceptions, but another problem with them is they can be very challenging to use, especially in the face of what's called mutable state, where things are changing. And with exceptions, there's something called the basic guarantee and strong guarantee. Who has heard of those terms? All right, there's one person. All right, so the strong guarantee is when I issue a command to, say, an object, and if it has the strong guarantee, it says, if an error happens, I will restore myself to the state previous to you sending me that command. So, for example, if it was a bank transaction and you were moving money from this account to that account, the strong guarantee would say, if there's an error in that process, I'm going to return to the state before you issued that command. That's the strong guarantee. The basic guarantee just says, I'm not going to guarantee what's happened here, but everything is going to be in a valid state after the fact. So implementing software so that it follows the strong guarantee and the weak guarantee, or the basic guarantee, can be non-obvious. And the last thing that I want to talk about, which, who has heard of monadic error handling? So this is quite an advanced topic. So there's one here. So this is sort of a new way of, sorry, it's an old way, but it's everything old is new again with Swift, because Swift is adopting or enabling these paradigms, these new paradigms to exist easily. So going back to our train example, we have our errors, and these things don't match together. I can't compose these inputs and outputs. It's a problem. So going back to the railway-oriented programming example, I'm doing what's called a functional bind here. I'm making my railway into something that I can hook together now, because now I can compose these things. So the bottom railway is the error line, and the top railway is the I've done something line. So if any error happens during this process, I sort of switch down over to the error state. And the cool thing about this is you can have these functional operators that join your functions together without actually having to worry or change the function signature significantly. And incidentally, somewhere at the end of the line, the sergeant perhaps has to take all of these things, the error, and they merge them back together and then report to the user, maybe the transaction happened, maybe it didn't. Swift introduces a type called an optional type. And if you look at any Swift code, you'll see these question marks and exclamation points in there. And that is called an optional type. And this is a type called a maybe type. And maybe just means maybe I have one of these things, maybe I don't. So here I have a user, question mark, means maybe I have a user, maybe I don't have a user. Now that is sort of limiting. And what Swift doesn't have currently, but would allow you to write, is an either type. So I can write an either type that takes, this is actually not valid Swift, but I just want to show the point. Here's a result type, it's an either type of a user, and it either has a user or it has an error. And what this is, what this either type allows, is this sort of input here. So I can do this actually both with optional types and with either types. Does anyone want to guess why an either type is better than a maybe type in this case? Anyone? Hey.
Maybe your choices are predefined.
Sorry.
The choices of what happens afterwards is predefined.
Yeah, right, okay. That's correct. What I guess I was thinking about with optionals is optionals have very little information with them. It's just I have it or I don't have it. So optionals work this way, but the problem is this second line just tells you, I don't have one. It doesn't give you information about, well, was it because their email address was blank? Was it because it was invalid? Was it because the server timed out? Was it because the database couldn't be connected to? So you lose all of that information with an optional type, whereas with an either type, you can carry that information along. And so this is sort of a new way of thinking of error handling, and the community is slowly adopting things like this. And if you go and look at some open source projects, you can see there's various either types that are being, or result types, whatever you want to call it, being created. I know of 6 different results types now in the community. So here's a set of milestones, and it's sort of my wish list about Swift. And these are things that I hope happen. So number one is shipping apps using 100% Swift. Well, the cool thing is that this one happened. This has already occurred. I have it's called Heart Rate Touch. It's an all Swift app. It's non-trivial. It does signal processing on the capillary action in your finger to check what your heart rate is. It's really easy to use, and you can go download it in the store. heartratetouch.com. So that's been done. Swift becomes a first-class scripting language. Maybe we're going to have an Automator example a little later. Automator, so there's some things that are really hard to express using a GUI, and Swift would be a natural fit. So right now you can use AppleScript and I believe JavaScript, and you can also do various shell scripts, but you can't use Swift yet. So that has to be coming next year in the next OS. Zero compiler crashes. There's this great project called Practical Swift, and you can run this set of tests where it will exercise the compiler and actually forcibly crash the compiler by entering invalid Swift. And writing a compiler is a really, really complicated thing. It's a hard problem. And to do it so that it optimizes well is a really, really hard problem. And actually, in the last beta, they reduced their error rate by a sizable amount, I think, in that test suite. But, of course, we need to get to zero compiler crashes. My fourth milestone that I hope for is for the diagnostics to become super awesome. So Swift right now, it generates errors. It generates errors when you compile. It checks your work. And that's great if it's actionable errors that you know how to fix, and it makes it easy to diagnose and fix those things. And it's not so great if it just says, I had an error and I'm going to tell you some random thing about that. The nice thing is Swift is being developed by the Clang team, and the Clang team has done wonders for diagnostics compared to the older tool chain, which was GCC. More powerful generics. This is actually a whole talk in itself. There are some minor shortcomings with the generic system in Swift that, if they improved, would improve the standard library. Third-party binary frameworks. So Swift is still in its infancy. So if you want to make a third-party API right now, you have to provide the source code for that. So at some point, it will become stable, so third parties can make their own libraries with Swift. And that'll be a huge milestone for the adoption of Swift, I think. I'd like to see in either type, either that or exception support, some sort of unified way of error handling. That might come with a Swift-only API. So Swift-only APIs are another milestone to come. Right now, we have these super powerful constructs in Swift called generics, and where you can write generic code that's statically type checked. It means that the compiler can make sure you have apples with apples and oranges with oranges and not mix up your functions. And so being able to use generics and value types and tuples and these parts of the language will be a huge milestone. This is my other strong wish for Swift, is that it becomes an open source standard. And I have strong hope for this because the LLVM team has a history of making stuff open. And it'll be great to see where Swift can go when it becomes an open source standard. For example, Swift in the browser. It's a definite possibility that happens if Swift becomes open source. Self-hosted. Okay, this is my wish list. But when I write, Swift right now is currently written in C++. But I hope at some point in the future, Swift is written in Swift. And that's what it means to be self-hosted. And finally, at the end of that spectrum, Swift OS. Maybe, who knows, maybe there's going to be a car interface that's mission critical, needs to have no errors, and they decide to write this from the ground up in Swift. It'd be a cool thing. So going back to John Siracusa, Swift is still very young but has a bright future ahead of it. If it succeeds, it has the potential to spread to every corner of Apple's technology stack, from server-side programming to installer scripts, maybe to the web. But Swift's role as a successor to Objective-C is important enough on its own. In a way that has that all past enhancements to Objective-C have not, Swift has the potential to ensure the viability of Apple's development platform for decades to come. And that is why I think Swift matters. Thanks. So, a quick time check, and maybe I'll take, I want to do a little bit of Swift programming to show you sort of what it's like to write a program in Swift, and I'm going to write a very simple program since I know there's a very mixed audience here. And I think, so we end at 8:30, is that correct?
Yeah.
So maybe I'll just try to do this quickly in the next 10 minutes, and then we can listen to some Automator stuff.
We're fine. You're good.
Right, so I'm going to open actually the released version of Xcode to do this. So I'm going to create a new project, and so I'm opening Xcode. And who has used Xcode here? Okay. So I'm opening Xcode, and I'm going to make a new Xcode project. And I'm going to make an Mac OS X application, a Cocoa application. And for those of you that use iOS, you might notice some striking similarities to how I put together this app. So I'm going to call this app Speak It. And the language I'm going to use is Swift. And so, just put it on my desktop. And so this builds some files here, it's like a template. And I have some source files where I write my code, and I have this thing called a storyboard that lets me define my user interface. And I'm going to make some room here, and there's some controls for making space. And so here I have my user interface. I actually need to get out. I want to put a text field, and I want to put it right in the center. So it's called a text field. So here I'm going to just drag out text field, and I'm just defining my user interface here. So I want this to span the screen. Okay, and notice there's these blue lines that sort of help me. I'm not used to using the small screen, sorry. Okay, so I'm sort of using those guides to help me. I can just sort of drag there. And now I do what's calling defining constraints. So I can control drag and say, this field, I want you to be centered horizontally in this container. And then it gives me some errors saying, hey, okay, I know how to put this thing in horizontally, but I have no idea what you want me to do vertically. So I can do that. I can control drag and then set this constraint, vertical constraint. Now it's still complaining because it says like, you drew me this way, but this screen could get bigger or smaller, and I don't know how bigger, much bigger or smaller. So I can control drag, and I want to say, I want to lock this edge to the leading side of the container, and likewise I want to take this edge, oops, and lock it to the trailing of the container. So now I have my text field there. Maybe I want to make a label. So there's a thing called a label. I'm just going to my little tools palette down here. I think it's called an NS label in this land. And I'll put my label here, and I'm using those guides again, and text to speak. And I want to constrain this guy. I want to say, oh, I want you to be vertically spaced over that guy. And notice he's getting some errors because it's great vertically, but it doesn't know what to do horizontally. And maybe I'll say I'm going to align these guys so that the lefts match up to one another. So I'm just adding constraints to this thing. And finally, I want a button. Not a UI button, but an NS button. And I'm going to make a gradient button here. And I'll say this button is speak. And I'm going to constrain it vertically to that thing, and I'm going to constrain it to that trailing space. And then I'm just going to give this guy sort of a fixed width of the width that I've defined right now. So here I'm going to run the program, and now I have my user interface. And notice when I scale, it scales with the constraints that I've given it. Now, unfortunately, it doesn't do very much. So now let's make it do something. So in order to what I want the program to do is when you push the speak button, I want it to say what's in the text box here. So I am going to go back to my storyboard, and then I'm going to click on this guy that's sort of the auxiliary view, and this shows me the code that corresponds to this screen that I have here. And so in order to connect code to my interface, I control drag from that widget. So here I'm creating an outlet, and I'm going to, this is sort of a way to communicate with this thing, and I'm going to call this text field. So now I have this named thing that I can communicate called text field. And for the button, I need an action to happen. So I'm going to control drag from my button out to here. And this wants to be an action. And so I'll call this speak pushed. Will be the name of that thing. And so that creates a function that gets called when that happens. So now I've hooked up my interface to the code. So now all I have to do is add the magic code in there. So let me go back to a full screen, and I'm going to switch over to my code, which is a view controller. And here in my pushed, I want to do something. So I need something to speak. And so I'm going to create a new property, and I do that with var. That means short for variable. And I'll call it maybe synth for synthesizer, and that's an NS speech. And notice Xcode, the thing I'm in, gives me recommendations for what I'm trying to type in. So I want to create a new speech synthesizer. So I'm just going to create one of these things. And so when my application loads, this new synthesizer called synth is going to get created. And then in my speak pushed action, I'm just going to say, okay, what's the text that you want me to say? So let's make a variable called message. Actually, I'll make it a variable. A variable called message. And that's what's in that text field. So text field dot string value is how I get that text field. So that gets put into this variable called message. And now I'll just call my synthesizer, which I named, I spelled that wrong, but oh well, we'll just go with it. And I'll say, start speaking the message. And now let's run the program. And I'll type something in, hello world.
Hello world.
I don't know if you can hear that, but it's saying hello world.
Hello world.
All right, so now in a couple minutes when we see the Automator presentation, you'll say, well, I could just do that in Automator. But programming is awesome. Programming is like a superpower. And let me show you sort of what I mean by that. I could make it say, and I don't expect you to follow this if you haven't done any Swift, but I could say countdown. And then I'll say, so countdown period. That period makes it pause when it speaks. So it's a useful trick. And then I'll say for n for number in a stride from 10 through 0, counting by -1. I want to add to this message. I want to add, it's saying that number, n, followed by a little pause, period. And then at the very end message, I want it to add in that thing from the text field string value. So now, in a few lines of code, we've made something that would be difficult probably to make using a graphical user interface. So blast off.
Countdown. Blast off.
Oh, I have a bug. I said message plus. What I meant to say was plus equals. Let's try that again. Blast off.
Countdown. 10, 9, 8, 7, 6, 5.
There we go.
3, 2, 1,
So
0.
I think
Blast
with that,
off.
I'll turn it over to Automator.